Good afternoon, I am Antonio Carrillo-Andrés from the University of Malaga. On behalf of my college, Xavier Apaolaza and Celestino Ruivo, I'm going to present a summary of 2 years of research on the thermal performance of solar cookers in Southern Iberian Peninsula. This communication summarizes the results of 2 years of Malaga-Faro research collaboration on the thermal performance of solar cookers. Some experimental facilities have been built in Malaga and we can test simultaneously several devices. We have tested various types of solar panel cookers. We have also made numerical ray tracing, and we have made some studies about testing protocols itself and data processing, and as a result some scientific papers have been published to date. Here in this slide we can see the experimental setup. This picture was taken on November 2021, and here we can see 3 Copenhagen cookers, 2 Heinz, 1 Simplicity, 1 Parvati, and 1 parabolic antenna dish cookers. All of them are being tested simultaneously, in total 8 cookers. These are the typical measurement devices. We use 5 thermocouples in water and some others to measure air or pot surfaces. We have 2 weather stations, a local one with 2 pyranometers and ambient temperature and wind speed, and also the faculty weather station that we use to check results. Here is the list of scientific papers published to date. There are 6. And now we are going to review each one very briefly. The first paper, it's called Experimental Determination of the Standardized Power of a Solar Funnel Cooker for Low Sun Elevations, was published in Renewable Energy. And we made side-by-side testing of 2 identical funnel cookers. We used a protocol based on the standard. We made a large number of tests, 41 for low sun elevation, and using azimuthal tracking. We used iced water to get more valid observation at the beginning of the tests. We introduced confidence and prediction intervals in the data processing to quantify uncertainty in standard power determination. And we found, for example, that the power of the cooker was at 46% greater if we use a transparent lid than a black metal lid. The data you can read on the slide. The second paper is called Performance of Solar Funnel Cookers Using Intermediate Temperature Test Load Under Low Sun Elevation, and was published on Solar Energy Journal. We made side-by-side testing of 2 identical funnel cookers, again for low sun elevation and azimuthal tracking, but in this case the standard was not followed. We used the cooker optothermal ratio and overall efficiency as parameters of performance. You can see the formula of the optothermal ratio. We used glycerin as working fluid so we can get temperature above the boiling point of water, and we found that solar cookers can get temperature in the range of 150 degrees with the use of glass enclosure, and 120 degrees without glass enclosure. Some other results are on the slide. The third work was called New Approach for Analyzing the Effect of Minor and Major Solar Cooker Design Changes, Influence of Height trivet on the Power of a Funnel Cooker. In this case we made again a large number of tests based on the standard, using water as the load, with different trivets. We found that trivet has a moderate influence on a standard cooker. It's around 5 watts, so experimental noise it's a problem. And we proposed a new approach to analyze data based on density plot of residuals. If you see the picture on your left, you see that on blue you have the power of a cooker using a trivet with 15 millimeters, and on orange you have the power of the cooker without trivet. So we can calculate residuals, the difference between these two lines, and we can make a density plot of these residuals. That is the blue line of the picture on your right. The average value of the distribution that we get, it's a good measure of the difference between the power of these two configurations of the cooker. And the results we get is that if we use a trivet of 25 millimeters, we can get 6 Watt of gain. With a 50 millimeters, we get 3 Watts, and higher trivets are detrimental. The fourth paper, it's called On the Use of Experimental Measured Data to Derive the Linear Regression Usually Adopted for Determining the Performance Parameters of a Solar Cooker, and was published on renewable energy. In this case, we were studying different approaches of modeling using intermediate temperature experimental data from very different cookers, a lightweight funnel using glycerin, and a heavyweight box cooker using peanut oil. And we found that in the case of the funnel cooker, the linear fit shows deviations from experimental efficiency, especially at the beginning and at the end of the tests. And in the paper, it is discussed the reasons behind. And for the box cooker, we found that the linear fit showed even larger deviations than in the case of the funnel cooker. The fifth paper is experimental thermal performance evaluation of different configuration of Copenhagen solar cooker, was published on Renewable Energy Journal. In this case, we study the well-known Copenhagen solar cooker. We follow the standard protocol and we made again a large number of tests. This cooker has 3 configurations called Flower, 90 and Cave. Each of them are intended to work in a different range of solar elevation angle. We study what is that range, and we found that the flower configuration, it's better if solar elevation is above 65 degrees, but 90 configuration is the better for the rest of the range. And the cave configuration doesn't seem to have any advantage. Many other results are on the paper. Finally, the sixth paper published to date, it's optical characterization of a funnel cooker with simultaneous sun tracking through ray tracing simulation. This is, we made a numerical ray tracing study using SolTrace. It's a software, and we use it to perform optical characterization of this cooker. And there are many results in the paper, but we found that the optical efficiency using realistic optical properties is around 1.37, so 37%. We also presented some radiation density flux maps, and we also studied the dependence of optical efficiency on the angle of incidence, which are the 2 pictures that you can see on the slide. Finally, conclusions of these 2 years of research work. We have worked a lot. We have learned a lot. We have tested several types of cookers. Besides the funnel in Copenhagen, we also have tested Heinz, Simplicity, Parvati, Crisol, and some others, but some others are not yet published. We have made some improvements in experimental facility and also in procedures. And we have introduced some improvements in data processing, some refinements to the standard protocol. Now we can use confidence intervals, or we can change the clustering intervals. We can use ice water. We can use density plots of residuals when we want to analyze a very small difference between configurations, for example. And now we are able to perform a numerical ray tracing for optical characterization of cookers. To date, we have 6 papers published. Others are in progress. For example, work in progress. Right now, a few days ago, this picture was taken testing 4 Carrillo cookers. Thank you for watching. We hope that our work will be useful, interesting for the solar cooking community. We will keep on working, and that's all. Thank you.